Hello, today's topic is limit laws. The CLT is one of the most remarkable theorems in probability. It helps us understand why the empirical frequencies of so many natural populations exhibit bell-shaped curves. Recall that IID means independent and identically distributed random variables. Now, see this theorem which says that let x1, x2, x3 are IID random variables, each with mean mu and variance sigma square. Then the distribution of x1 plus dot 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 plus xn minus n mu whole divided by sigma root over n, which tends to the standard normal variate set as n tends to infinity. Then we can say that probability of x1 plus dot 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 xn minus n mu whole divided by sigma root over n is less than equals to b, and it is nearly equals to probability z, which is less than equals to b, and it is equals to capital phi of b, where capital phi is the CDF of standard normal variable when n is large enough. Okay, now so CLT helps us to approximate the probability of anything involving x1 plus x2 plus dot 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 plus xn, where xi's are IID random variables. When approximating discrete distributions, used the plus minus 0.5 continuity correction. Now let's understand this concept with an example. Here we have been told that an instructor has 1000 exams that will be graded in sequence, and the times required to grade exams are IID with mean mu equals to 20 minutes and standard deviation is equals to 4 minutes. Approximate probability that the instructor will grade at least 25 marks or at least 25 exams in the first 450 minutes of work. Okay, I repeat that an instructor has 1000 exams that will be graded in sequence, and the times required to grade exams are IID random variables with mean 20 minutes and standard deviation 4 minutes. Now, approximate probability that the instructor will grade at least 25 exams in the first 450 minutes of work. So, let's start the solution. Let xi be the random variable which implies the time it takes to grade exam I. The time it takes to grade it takes to grade exam I. Okay. Then x equals to x1 plus x2 plus dot 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 plus x25. Then x is the time it takes to grade the first 25 exams. Time to grade first 25 exams. Then we want the probability that capital X is less than equals to 450. Now, to use the central limit theorem, first we need n mu and sigma root over n, because the mean of xi, which is mu, and the variance or the standard deviation of xi is sigma. Therefore, the mean of x is n mu and the standard deviation of x is nothing but sigma root over n. As we have been told that mu is equals to 20 minutes. Therefore, n mu is equals to 25 multiplied by 20, that is 500. And as we know that the sigma is 4 minute, therefore sigma root over n is nothing but 4 root over 5, which is equals to 20. Now using this information, we can have the probability x is less than equals to 450 by just subtracting n mu from x and dividing the whole thing by sigma root over n. And in the right side, we also do the same thing. Therefore, we get probability x minus 500 divided by 20, and in the right side we get 450 minus 500 divided by 20. This is a standard normal variate, which um, conventionally denoted as z, and in the right side we get minus 2.5. So we can write it as 1 minus capital phi of 2.5, where phi is the CDF of standard normal variable, and using the normal table we can have the answer as 0.006. So this is the answer of our problem. Therefore, we can say that the approximate probability that the instructor will grade at least 25 exams in the last 450 minutes of work is nearly equals to 0.006. So that's all for today. Thank you very much.